Welcome to the Rooted in Ag podcast, part of the We Are Extension podcast series broadcasted through Douglas County Extension in Lawrence, Kansas. Rooted in Ag refers to the deep connection and importance of agriculture to a region's history, culture, and identity, as well as the practical aspects of food production and land management. Gather around the table. Together, we can be rooted in ag as a symbol of regeneration, resilience, and hard work, celebrating our enduring connection to the land. We will also get down to the latest best management practices in farming and ranching as we meet producers and practitioners, sharing stories and resources of new technologies aimed at improving sustainability, innovation, and food security. Let's get started. Welcome back to Rooted in Ag. I'm your host, Margit K, agriculture agent with Douglas County Extension. And whether you're a farmer or an agricultural enthusiast, we hope you can walk away with some useful knowledge today. So harvest dust is settling out of the air as harvest wraps up. Combines are heading back to the shed. And of course, farmers are tallying yields, hauling grain, and planning for next year. So it's been a quandary of a year in a way. There's been a steady increase of fertilizer prices. As of mid-October, the anhydrous prices were probably the highest we've seen in a long time, $816 a ton, and are expected to be at over $1,000 a ton by next spring. And then urea at about $507 a ton, liquid nitrogen $435 to $480 a ton. This has been a 15 to 29% increase of prices year on year to 2024. And corn prices have been also just steadily declining throughout the year. And so kind of put it in context, if we have an average application rate of 144 pounds of nitrogen per acre, it's only a 20-acre field where you're over a ton of some form of nitrogen fertilizer, so anhydrous ammonia particularly. So this makes for a higher nitrogen to corn price ratio, the highest we've probably ever seen, 0.15 versus the average of 0.90 as of October 1st. So nitrogen to corn price ratio is expressed as price of nitrogen fertilizer per pound to the price of corn per bushel. It's a key economic indicator for farmers. A higher ratio, of course, means nitrogen is more expensive relative to corn, making it more profitable to use less nitrogen, while a lower ratio suggests nitrogen is relatively cheaper, making higher application rates more economical. So as the dust settles, of course, one question keeps coming up. How can farmers increase or maintain soil fertility when margins are this tight? It isn't all about nitrogen, though. And so today we're going to look at a solution that's both old and new, cover crops, traditionally known as green manure crops, and how they can help feed the soil while easing your fertilizer bill. So to help unpack this, I'm joined via Zoom by a familiar name in soil health, Keith Burns, co-owner of Green Cover Seed and co-founder, business visionary of this company out of Bladen, Nebraska, with a location in Iola, Kansas, one of the major cover crop seed providers in our region and educators in the United States. With over 25 years of no-till farming and 10 years of teaching agriculture and computers. Keith, you are no stranger to this topic, of course. Welcome, and thank you for being here.
Yeah, absolutely, Margit. Nice to join you. And I've got good news for everybody. Cover crop prices have gone down since last year, not up. So there's a little bit of good news for people.
That is awesome. For sure. For sure. And I know that, this whole topic of regenerative agriculture, as we're talking about incorporating soil health practices, it's all about restoring, rebuilding, revitalizing life in the soil and all life above the soil, including plants, animals, and human health. So I'm excited to get started talking with you about this in more detail. And I think the best place to start, of course, is talking about what cover crops are and why they matter. So give us your little spiel about it and how you want farmers to think about this, because I think there's still a lot of misunderstanding. It's like an old lost tradition, right? That's making a comeback.
Yeah. The old has become new again. And really what modern day regenerative agriculture is, it's combining the best of, the way that our great grandfathers would have farmed with a lot of the modern technology that we have today. We're not wanting to throw out any of the good parts, but we're bringing them all together. And so cover crops just simply are plants that are going to get planted, and between the main periods of cash cropping, they are not designed to be harvested. They're designed to improve the soil. They're designed to fix a problem. And that problem might be soil erosion. That problem might be lack of infiltration. That problem might be, I don't have enough nitrogen for my next crop. So depending on the problem that you want to solve, that's where we can try to dial in what cover crop, because We have over 100 different types of plants that we use as cover crops, and you really have to know what problem you're trying to solve before you can figure out what cover crop you need to use.
For sure. Yeah. And there's so many variabilities as we'll get into when they can be planted and all that. Well, what are the benefits then of the cover crops in the short term and longer term?
Well, we like to think of the cover crop as, everybody knows what a Swiss Army knife is with all the different blades and all the different little tools on it. It's a multi-purpose tool. You can do lots of things with it. And it's the same with cover crops. And so we can fix nitrogen, we can prevent erosion, we can provide supplemental livestock grazing, we can provide habitat for beneficial insects, we can break up compaction. The list goes on. There's just a ton of different things that cover crops can do. Probably the biggest things, though, the most, visible things would be that prevention of erosion, because we can all see when our soil washes away or blows away, and that just hurts the soul of a farmer to see that. And so that's pretty easy to prevent with a cover crop. The growing of nitrogen, as you mentioned, in your beginning, that's becoming a more and more important topic as those prices go up. Margit, one of the things that we've really discovered as we've been in, the cover crop business now for 16 years is we didn't appreciate the value that the biological community brings to the production system. And one of the best things that cover crops do is it enhances, it expands, it supports the biological community in your soils. Now, we don't completely understand it yet, but we know that how important it is, and we know that they can't live in the absence of a green and growing plant. So that's maybe one of the most important things that cover crops do. It keeps your biology alive.
Yeah, it feeds them, right? And that's through the release of the plant sugars going down through the roots, the exudates, we call them, that are like liquid carbon. It's liquid sugar from photosynthesis, right? Good old photosynthesis has been around for
That's right. Take
millennia.
you back to sixth grade science.
And therefore, those organisms have evolved with the plants and are, as I understand, like species-specific organisms to different families of plants or species of plants. So I love the way you guys blend all these different mixes together of cover crop mixes and how diversity can be reflected above ground, but it's also feeding a more diverse microbiome in the soil. And what all is that doing? I don't know. I think we're all just kind of wrapping our head around it. It's like you said.
Yeah, it's a bit of a black box in that we don't exactly know. Now, I will say that, the last several years have brought some really good advances in, metagenomic and DNA sequencing. The test that would have cost $10,000 5 years ago, you can get for a couple $100 now. And so that will continue to come down. We'll be able to see more of what's going on by looking at the DNA of everything that's out there. Now, they can't identify a lot of it yet, but again, they're working on that. That's getting better, and that's going to give us probably our best glimpse into what's going on. But you're right about the diversity. I mentioned all of the different things that cover crops can do, but not every cover crop can do all of those things. And so if you want to accomplish multiple goals, we're going to need a mix. We're going to have, some legumes. We're going to have some grasses. We want the deep-rooted broadleaves and brassicas and forbs. And so, understanding what those goals are will lead to what that best mix is, but we always want to see it go out in diverse mixes because that's how God created plant communities to grow together. Look at any native natural prairie.
Yep.
You don't see a monoculture out there. It's always a diverse mix that has been well adapted to the growing environment. And that's really what we're trying to emulate when we put together a cover crop mix is, what kind of diversity do we need to bring to the table to solve the multiple problems that the producer has?
Yeah, for sure. That's where there's that beauty in learning how to manage these different options. And one of the things I would love to hear you kind of share with our listeners about the way that this microbiome is also actively generating that nitrogen in the soil, the free nitrogen. What is that? Can you help explain that a bit?
I'd love to. Yeah, this is one of my favorite subjects because it's incredible when you look at the numbers. So, you mentioned all the numbers about nitrogen and, I was just doing a little mental math in my head and, that's going to be getting up to 70, 80 cents a pound of nitrogen, which is kind of silly based on where the prices of corn are, but that's a whole nother, that's probably a whole nother episode. But guess what? Above every acre of crop ground in Kansas and Nebraska, all across the world, we have 30,000 tons of nitrogen in the atmosphere above every acre of crop ground. 30,000 tons. Now, it is a 100% unusable by the plants directly. And the reason for that is the good news and the bad news. The good news is because it's in an inert form, it's two nitrogen molecules bonded together as dinitrogen, three sets of very strong covalent bonds. It makes it inert. And the good news is it doesn't kill us.
Well,
Because,
we
because
beat
if it
it.
wasn't inert, we would just all literally melt from the inside out. So that's the good news. The bad news is just as it does not affect our lungs when we breathe it in, plants can't do anything with it. So
Mhm.
when they're taking in the atmosphere to get the CO2, which is only 4/100ths of 1%, the nitrogen is at 78%. When they're taking in to get that CO2, they're taking in vast amounts of nitrogen, but the plants can't do anything with it. They were never designed to pull that atmosphere directly out, to pull the nitrogen directly out of the atmosphere, but the biology can. And so there's things like rhizobia bacteria that will form colonies on the roots of legumes, and they can be very efficient, and they can produce the right enzymes, the right chemicals, and they break that nitrogen bond. They combine it with hydrogen and oxygen, and they make forms of nitrogen then that the plant can use. And all the plant has to do, pretty cheap trade-off really, all the plant has to do is feed them, and it feeds them that liquid carbon
Mhm.
that you were mentioning that's produced through photosynthesis.
Mhm.
So that's great news for legumes, and like soybeans can produce 300 to 400 pounds of nitrogen in 60 days. Pretty incredible, really.
Mhm.
But what about corn? What about
Right.
wheat? What about these other things? Because they're not legumes, they can't form those associations with that rhizobia. But there's good news there too, because there are lots and lots. In fact, they're discovering new ones all the time. There's lots of what's called free living diazotrophs or free living nitrogen fixers. They don't have to associate with just a legume plant. They can associate, they can trade, they can sell, if you will,
Mhm.
their nitrogen to a corn plant or to a wheat plant. Now, the trade off, though, or the thing that we have to remember is that while rhizobia form colonies and there's billions and trillions of them working together to form those nodules you see on
Mhm.
soybean roots, and that's what makes them very productive, very efficient. These free living ones are single celled organisms. They're kind of, independent contractors, if you will, instead of a whole factory of workers. And so they're not going to produce as much nitrogen, but you can still get 50 to 60, maybe 70 pounds of nitrogen contribution throughout the year, which is significant. And it makes a huge difference. It may not be enough to grow your 200 bushel corn crop, but it's enough to supplement it. It's enough to
Mhm.
grow a really nice grazing crop. And so people that have
Mm.
livestock, in their operation and they're cycling that nitrogen back through because they're not hauling it all away in a
Yeah.
hay bale, a silage truck, or a grain truck. That nitrogen stays in the system and it cycles and it
Mhm.
builds.
Mm.
And that can be very effective and very, productive systems without having all these outside nitrogen inputs.
Yes, and it becomes a more stable form of nitrogen, doesn't it? Kind of with the humification, and you get into all that other deeper soil science, but we're not going there today. We're just trying to introduce it, but
Yeah,
yeah, for
yeah.
sure. And so, what are the key conditions, though, to create that hospitable environment for these bacteria? We know they exist in the quadrillions, right? One tiny teaspoon of healthy soil has what, 10 billion estimated single cell organism, bacteria, the microbiology. But what really makes it attractive for them to create this environment? But they kind of help create it, but they also need it to get started. So it's really a two-edged sword in a way.
Right. Yeah. So number one, you have to have a plant. These things are not going to work in the absence. Well, I'll take that back. Most of these are not going to work in the absence of a green growing plant. I
Mhm.
learned something just the other day that I'll share in a little bit that kind of takes away from that just a touch. But it needs a plant
Mhm.
because as cool as breaking that nitrogen bond and making that nitrogen available, those bacteria, they can't live on the nitrogen. They have to have carbon. That's
Mhm.
their food source. And so the plant has to be there
Yeah.
to pump out the carbon through its root system, through those liquid root exudates to feed the bacteria, whether it's rhizobia or the free living diazotrophs. They need that liquid carbon in order to survive. So you got to have a green growing plant, first of all. And then, of course, that plant has to have water and sunlight and, of course, all of those things. So that would be, the number one most important thing is you can't do most of this in the absence of a plant. And then number two, this is not going to happen if you have excess nitrogen in the system because plants are actually pretty smart.
And lazy.
In fact, they're smarter than some people I know because if they're making an investment and they don't get a return, they stop making the investment. And so if they're putting carbon into the soil and there's no biology there to return a benefit, they stop putting the carbon as much into the soil. But plants are also very efficient and they are not going to spend their liquid carbon resources to encourage the biology to make nitrogen if there's free nitrogen available. And so that's why you don't want to have excess nitrogen carryover ahead of soybeans. You make them lazy because they're not going to encourage the nodulation of rhizobia. They're just going to suck up all the free nitrogen first. So that's where a cover crop can be huge. You have carryover nitrogen after corn. You need to get that tied up in rye or oats or something like that. So when the soybeans start growing, they don't see any nitrogen in the soil because it's held in the cover crop. It forces them to form those rhizobial associations immediately. And then later on, as that cover crop disintegrates and dissolves back into the system, that nitrogen then gives it a little boost later in the season. So too much free nitrogen will interrupt this whole system. And frankly, that's part of the problem of our modern ag, the way that we farm is that when you're putting all that nitrogen out there ahead of time, you essentially are telling the system, thanks biology, but no thanks. We don't need your help. We've got it covered. And so you're missing out on all of that when you're front loading the system with all of those heavy nitrogen applications.
Yeah. Wow. What a beautiful explanation. And of course, this is totally leaving out the fact that those microbes are also accessing other macro and micronutrients. And we're not even talking about the whole mycelial network of the mycorrhizal fungi and their role in transporting and translocating these nutrients. But obviously, go ahead.
And I wanted to share one more thing since I kind of teased it earlier. So I learned just the other day in talking to one of the manufacturers of the biological products that we use that there are organisms. So like right now, harvest is done. Okay, even if there's not a green growing plant out there, there are certain microbes that will work on, they'll take the carbon out of all of that corn stubble. And instead of pulling nitrogen, because that bacteria needs to balance their carbon nitrogen ratio, they got to get nitrogen from somewhere. So instead of pulling it out of the soil, they're actually fixing atmospheric nitrogen without a plant because they're pulling the carbon out of the residue. They're pulling the nitrogen out of the atmosphere. They're breaking that down and then making all of these nutrients available for the next spring. So we want to learn a lot more about that, but there's some really unique products out on the market right now that help with that decomposition. And it's not just releasing what's there, but it's adding to the system because it's pulling atmospheric nitrogen to do it. Pretty cool.
It is pretty cool. And of course, it happens in a cooler environment, like during the winter with that slower decomposition and yet that, again, it's a humification process so that it's all ready when the crop needs it in the spring. And it's almost like the theme of this podcast is banking your nutrients. So that's right there. So in the meantime, I think that this has been a great overview of it all. And I know that we talked about cover crops and their role in aiding the soil and creation of this free nitrogen. So you mentioned already some of the innovative testing. And if we can just touch back on that just a little bit of what you foresee is some of the noticeable changes. You mentioned the DNA sequencing, metagenomics, and all this stuff that's been happening with precision ag. What are some of the other tips or tricks, methods farmers can use that are really accessible? Maybe it goes back to that DNA test you mentioned that's a fraction of the cost of where it had been. But just to reiterate, perhaps.
Yeah, I mean, the DNA test is really interesting. it's still expensive enough that you're not going to do it, wide scale in all your acres right now. So I would encourage people to look at it just to, get that big overall profile of what you got going on. But the things that I think are really helpful in production ag today, some sort of biological test. So whether it's a Haney test or other labs are doing very similar things, calling it a soil health test. Because when you do that, you're going to get the traditional soil tests that you're used to. It's going to tell you how much, NP and K you have. But then it's also looking at the biological fraction of that. It's using some very natural organic acids. It's looking at the CO2 respiration of your organisms in the soil. And what it does is it gives a more accurate prediction in biologically active soils of how many nutrients are going to be released or freed up in the biological process. And so in any kind of healthy soil, you will almost always see lower fertility recommendations from that Haney test because it's showing you more available to the system that just a regular chemical test isn't going to show you. So something like that, I think, is a really good investment. And those are going to be more than a traditional soil test, but, maybe like twice as much. So it's not
outrageous.
It's not prohibitive. Yeah. So I think those are really important that you do that you look at it and that you consider, especially, when nitrogen is going to be costing 70, 80 cents a pound, that can pay off in a hurry because it's not uncommon for those types of tests to show you that you have anywhere from 30, 40, 50 pounds of additional nitrogen that's going to come out of your biological system. And the healthier your soil is, the more of that you'll see. So I really like that one. Another one that's really interesting that people should be doing is what's called a total nutrient digestion or a TND test, because all of these other tests are just showing you the nutrients that are available to a plant. And that's what it needs to do because that's what the plant can get. But the TND will show you all of the nutrients that you have in your soil. So it's showing you your savings account, your long-term savings, and it will blow you away how many nutrients you have in your soil. And then that should be an encouragement to every producer then to figure out, how do I get more biology? Because the biology is the key that's going to unlock that and make that available for your plants. So the TND test is a good one to just see what you've got. PLFA is another one that people can do that gives a little bit of an indication of how biologically active your soil is. And again, it's going to be significantly less money than a DNA test.
Yeah.
Doesn't give you near as much detail, but it's quite a bit cheaper.
Right. And of course, those are available. I'll put the links in the show notes of where people can access these newer tests. But it's exciting because I think it's the first time we really begun to understand what key role that we can measure now. So the biological measurement is a reflection, a metric that we can then go. So meantime, I think we're going to be just wrapping up here. We know that regenerative ag is a worthwhile transition, and there'll be resources I put in the show notes as well. Just touch briefly on some of the myths of the risks of transitioning to regenerative agriculture. I know that a lot of farmers are very hesitant, right? And when prices and cost price squeezes are so tight, but it's a long-term investment for generations to come. But tell us just briefly, how do you overcome some of these challenges in the best way?
Well, I think the biggest myth is that you're going to be less profitable when you do it, especially in those initial years. And that certainly can happen if it's not managed properly. But one of the biggest myths is that the more yield you produce, the more profitable you're going to be. And that just simply is not true, because sometimes more isn't better. It's just more, and it costs you more money to do it. And so, with regenerative agriculture, you make money by either increasing your production or decreasing your cost. And with regenerative agriculture, what many producers have seen is they may not necessarily increase their production a lot, but it doesn't go down that much, and they're dramatically reducing their cost. Weed control, fertility inputs, insecticides, fungicides. I'm not saying you're going to eliminate them, but we can reduce them. And so I think that's the biggest myth, is on that profitability side. So yeah, it's a risk to do anything different, but you know what? If you don't try things differently, you're going to get the same thing you've always gotten. And right now, that's not serving us very well.
Yeah, it's become more difficult. So I think that, again, there's local resources for cost share opportunities for cover crops. Those applications are closed for this 2025 fall winter planting season, but they're still taking applications that will be funded next year. And that deadline's always June 1st through our local conservation district. And then, of course, course, we do take in soil tests through the K-State Soil Lab that are available here through Douglas County Extension. And we do have one of those Kansas Soil Health Alliance soil test buckets for helping to monitor some of the physical characteristics or indicators of soil health, which again is just available for rent, borrow, bring it back kind of thing. I can show you how to use it if anyone's interested. It's a great indicator test for all the aggregate stability and even the rainfall infiltration test. Wow, our time's coming to an end, Keith. I know we could probably just go on about it, but thank you so much for joining us. I know that you guys have just released a new book called Cover Crops from Green Cover Seed. I don't know if you have any other final thoughts or message you want to share about ways farmers can learn about cover crops or taking steps towards regenerative agriculture.
Sure. Well, our website has tons of free resources. So yes, we just published a book. You can go to our store and you can buy a physical copy, but you can go to our website and download a PDF of it for free. We've got resource guides we put out every year. There's tons of webinars and all kinds of great content on our YouTube channel. So it's never been easier to learn new things, and there's just lots of great content out there. So we would just encourage you to be a student of the soil, observe what's going on in your own soil, and then put the effort into educating yourself about a lot of these concepts that we talked about, because there's lots of good information available, and a lot of it is free.
And it makes sense, right? Because it's working with nature, and there's always a forgiveness, I think, in working with the creation and having that resilience come back that can really help move things forward. So I know that I'm going to just mention, too, they're hosting a Southeast Soil Health Conference December 10th, 11th, 12th. Is that it?
Yep, that's correct.
Coming up in Iola, Kansas. So, well, thank you so much, Keith. It's great to see you, and we'll definitely be in touch. So,
all right. Thank you, Margit. Thanks for the opportunity.
And thanks to our listeners. One thing I'd like you to take away from today's podcast is cover crops build resilience biologically, agronomically, and economically. We might not be able to control the market, but we can control how we care for the soil beneath us. Feed the soil, and the soil will feed us. Until next time, stay rooted in ag.
Thank you for listening to K-State Extension Douglas County's podcast. We hope you tune in again for not only more research-based information and resources you can trust, but also good conversation. Until next time.